All right. So this morning we're going to start a new lesson on order of operation. Someone read the essential question to me, please. Hannah?
Why is it important to follow an order of operation?
Okay, so today we should be thinking about why is it important to follow an order of operation. Someone read the learning objective for today. Learning objective is telling us what we should be able to do by the end of the day. Cornelius, read the first bullet, please.
Students will be able to evaluate algebraic expressions.
Good. Justin?
Students will know what order in which to solve
Algebraic.
algebraic expressions.
Good. Hannah?
Students will be modeled algebraic expressions.
Great. Cameron?
Students will be able to construct
Viable. Arguments. And critique.
the reasons of others.
Good. Okay, so it seems like a lot, but when we go through it, we're just going to create an I can statement to see what it is that we should be able to do in your own terms. So looking at our learning objective, what can you tell me stands out so that you should be able to know what we're doing at the end of the day? William?
We should be able to solve algebraic expressions.
Solve algebraic expressions. What else? Cornelius?
Model. We should have the knowledge of how to model algebraic expressions.
Okay, so we're going to be able to use models. So model anything else? Eric? Great, and to know what order to solve algebraic expressions. Okay, and the very last one, it says students will be able to construct viable arguments and critique the reasoning of others. So today, we're adding that learning objective because I want us to be able to question one another as far as how we know something is correct or how we know something may be incorrect. Okay? So I'm going to put that here as also one of our objectives today. So to question the reasoning or the reasons of our work. Okay? All right. So to start our lesson off, we watched this video before. So we're going to start off with this video this morning. And you can sing along because, I know some of y'all can't help it.
Next we multiply and we divide. 16 times 2 is 32. Oh my. 32 divided by 4 is 8. And then we add or subtract, okay? 8 minus 5 is 3. Which is easier than writing this to me. Cut through your operations just like a surgeon. Look at it. Yeah, we keep it working. I've been first and I've been last. Either way, I keep the order with PEMDAS. First is parentheses, then it's exponents. Multiply, divide, and subtract. Yeah, you know this. I've been first and I've been last. Either way, I keep the order with PEMDAS. First is parentheses, then it's exponents. Multiply, divide, and subtract. Yeah, you know this.
All right. So just a little reminder of what PEMDAS is. That is a catchy song. Now go ahead and copy down this algebraic expression. Go ahead and copy down this algebraic expression on your paper. Who can tell me what the expression reads? Ariana?
3 plus 4 times 4.
Great. 3 plus 4 times 4. Okay? So, using the order of operations, okay, what would come first? Who remembers what would come first? And I'll write it here on the board. What would come first? Hannah?
Multiplication. I
Okay.
mean, not parentheses.
Parentheses. Great. So I'm going to put P and then put parentheses here. What comes after parentheses? Exponents. Great. Okay, so again, when we have our exponents, it's going to be whatever this is. So that's what an exponent is. Okay, what's after exponents? Yes? Multiply.
I got a question.
Okay. Okay.
For exponents, where 2 is, don't you have to multiply twice?
Yes. Okay, or whatever number that is. Okay. What about after multiplication? What comes after multiplication, Quantez? Division. Okay. What's after division? Hannah?
Addition.
And subtraction.
And last is subtraction. Okay. So now, looking at this problem here, 3 plus 4 times 4, we don't have parentheses or exponents, correct? Okay. So what I want you to do is let's go ahead and just solve this from left to right. So go ahead and put out 3 cubes in front of you. Just 3 cubes. Put 3 cubes out in front of you. Okay, good. Just 3, put it down in front of you. Okay, so these first 3 cubes represents what number in our equation? 3, okay? The 3 here. Now, next to that, put a 4 by 4 array.
Okay.
Put a 4 by 4 array next to it. Not attached to it, but just to the side. So you should have 3 floating on its own, and then a 4 by 4 array. How do I know if I made a 4 by 4 array correctly? Justin?
Because you count down, then you count across.
Okay. Can we use terms that we know what is down and across?
I forgot that.
Okay, say that again here.
Columns and rows.
So we need how many columns?
4 columns and 4 rows.
4 columns and 4 rows. Great. Great job. Great job. Great job. Okay. Why did we write 4, or why did we create a 4 by 4 array?
Because it said 4 times 4.
Say that again?
Because it said 4 times 4, and it was saying that we had to do it away with it.
Okay. So this 4 by 4 array represents what in our equation?
4 times 4.
4 times 4. So Now, can you tell me what the answer or the, what is the answer to our algebraic expression here?
16.
Okay, so we have a debate. Okay, hold on. We have a debate. Hannah, why do you say that the answer to this equation is 16?
Because if you can count for we just go 16, and then you got your columns and rows, you can count it to get your answer.
Okay, great. Now, Paris, tell me why you think it's 19.
Because multiply comes before add, and I multiply 4 times 4 is 16 plus 3 is 19.
Okay, so she added plus 3, Hannah. Why did she add plus 3?
Because 16 plus 3 equals 19. And then,
But why did she add 3, though?
Because it's like PEMDAS, because you can start with multiplication, and then you got addition. So when you get your answer 16, you put 3 plus 16, which added to 19.
Great. You want to add something, Cornelius?
And just like it says in PEMDAS, first is parentheses and exponents, and then multiply. And then after she multiplied, she had added 16 plus 3, which equals 19. And because the reason she got 16 is because the 4 by 4 is equal 16.
Great. Okay, so here is my model or example of what yours should look like. Okay, now Hannah, do you see where you might have had not finished the problem? Okay, so here we have our 4 by 4, which equals a total of 16. Okay, then we added 3. Okay, now go ahead and just mix up your cubes again. Now I want you to do put 3 plus 4 first. So add 3 cubes plus 4 cubes. 3 cubes plus 4 cubes. 3 cubes plus 4 cubes. Which would equal what, class? 7. Okay? Now put those 7 to the side.
Floating?
You can do floating if you like. Just put them to the side. Okay? Now, if we have 3 plus 4, which equals 7, the rest of our equation tells us to do what with that answer? Multiply it by 4. Now, get 4 more rows or columns of 7. Okay, and if you need more cubes, just let me know. Right, so that our equation is now 7 times 4. Because you have 7, you can use them as columns or you can use them as rows. Okay, if you need assistance, it's on the front board. Okay, so Ticos, you put how many groups of 7?
4.
4 groups of 7, right? Okay, how much did you get?
28.
28. Okay, we're finishing up here. Let me know, raise your hand if you got, or just tell me how many cubes you got at the end. What was the product of 4 times 7?
28.
28, you got 28 as well?
I got 28.
You want us to add the 3?
We already added the 3. Where did we add the 3?
At the beginning.
At the beginning. Okay. Okay, I need one person in your group to create the first equation of 3 plus 16 in one color. And then I need another person to keep the array they have now, the 7 times 4. Okay, so Cameron's going to keep it 7 times 4. The other person is going to do the first equation we did, and so everyone else put away their cubes. Okay, so you should only have 2 different models out. Okay? You should only have 2 models visible. Now, go ahead and talk with your group. why you think, or tell me with your group, which one you think is correct as far as solving 3 plus 4 times 4. Which of these models is the correct model to represent 3 plus 4 times 4? Okay, talk about it. Why do you think that's correct? Support your answer with some evidence.
I think it's this one because 3 plus 4 times 4 is 19 because 4 times 4 is 16, 17, 18, 19. And this equals 19.
Why did you say 4 times 4 first?
Because first you got to multiply, then add.
Okay, good. So what is that called when you do that in a specific order? PEMDAS, or the order of operation, right? Okay, so what do you ladies think? Do you think, which one do you think is the correct answer or model for that operation?
This one.
Okay, why do you think that you said the yellow one?
Yeah, I think yellow one.
No, I don't think the other one because it's 18 and that equals 16 plus 3, 19. And hers is the closest answer.
Closest answer, but let's think of why that is the correct or closest answer. She gave me a good explanation. I just want to see what you're thinking.
Because this 28 and I don't think that it's like the right answer. And like hers is more, it's more, like it was 19 and hers was.
So what are you going off of as far as a guideline to help you solve this? What are you going off of to help us figure it out?
The array.
Okay, the array. So what does the array represent?
It represents 4 times 4 plus 3.
4 times 4 plus 3. Okay, so that, like she said earlier, she's using the order of operation to help her solve it. Okay, so if we would have done, 3 plus 4 first, right? Which would equal 7, and then we multiply, would we have gotten the correct answer?
No.
No, because we're doing it in the wrong order, okay? All right, great. Go ahead and clean up here. The equation was telling us to evaluate 3 plus 4 times 6, okay? So Ariana, explain to us what you did in order to be successful on this question.
First, I had wrote 3 plus 4 times 6. And then I did 3 times 4 times 6, and that was 24. And then I added it plus 3.
Okay, good. So now, why did you multiply first?
Because we didn't have no parentheses and we didn't have exponents. So then I multiplied. And then I skipped division and I would get addition.
Great. So you used what to help us?
PEMDAS.
We used PEMDAS to help us out. Okay? So here, Ariana, if I would have added 3 plus 4 first, would we get the same answer? No. Okay? So in your array here, I see that you created a 4 by 6. And I think we're just missing 3 little squares, but we're going to go ahead and add those in here in our model, okay, which is just fine because your equation still shows at least the multiplication piece, but now we would have just added the 3 little cubes to represent 3, okay?